Hi and welcome to Unit 1, Topic 2, Video 3, and in this video we're looking at combining vectors using vector arithmetic where vectors are in polar form. So this will be a video about adding and subtracting vectors in particular, but the vectors are in polar form. Now of course we have two options and you can see them on the screen now, and I'm going to go through the component form option first and then the cosine form. So the component form option involves taking our polar form, converting them into component form, doing that really simple addition, I component and j component, and then converting back to polar form if that's required. The cosine rule involves considering our two vectors and building a triangle out of those. And they both have their benefits, but let's run through them first. So first, a diagram. Okay, so you can see the diagrams have been created there. We've got one on length 7, which I might rewrite. This is vector A, and it's on an angle from the positive horizontal axis there of 105 degrees. And then we have one of length 3 on an angle of 40 degrees. And I'm going to combine these together, but first I'm going to put them into component form. I've defined my I and j as usual in both cases. So the component form will be work out the horizontal, that's the I component, work out the vertical, that's the j component. Now with the first one, we've got a really good example here of how we could take the 105, turn it into a 75, and then convert back into component form using trig ratios because we have a right angle triangle. And that would mean, so that I'm going to put this down as option 1 because I'm just going to talk about another pattern in a moment. But option 1 will be that the I component is the base, which is the adjacent side here. That's the I component there. And so it's equal to 7 cos of 75. I'm just going to zoom in on this now for this bit. And the j component is equal to 7 sine of 75. And therefore A is equal to 7 cos, which is 1.8117i, plus 7 sine 75, which is 6.7615j. So there's the component forms. Now, the only problem we've got with this is because we've converted to 75 degrees, we have to be careful we consider of negatives and positives. And in this case, we can see the I component is negative. The j component's positive though. Now the fix is that actually we don't even have to worry about converting to 75 degrees. A, and this is option 2, is simply equal to 7 cos 75i, 7 cos 105i plus 7 sine 105j, and as you recall from math methods, cosine in the second quadrant is negative, which will give us our negative. Sine in the second quadrant is positive, and that will give us our positive. So your calculator will just automatically push out negative 1.8117i plus 6.7615j. Job done. So we're going to do that for the second one now, and just use straight up b is equal to, and now of course it's in the first quadrant anyway, but 3 cos 40i plus 3 sine 40j, and that simplified is 2.2981i plus 1.9284j. So we've got our I and j components, and so then we can calculate a plus b is equal to 0.4864i plus 8.6899j. Done. Now the other question is, of course, the 2a plus 4b, and 2a plus 4b is just simply 2 times vector a plus 4 times vector b, and so we can work this out fairly easily as 5.5641i plus 21.2364j. And so there's my response. Now I'm doing this in 4 decimal places, which is always a good way to go, but I am maintaining my answers in my calculator. So it's always also good to keep your accuracy. Now I do need to keep in mind that the question was given to us in polar form. So this is the big downside of doing it this way, because converting into component form and then back is pretty easy. The nice thing about this is I could do it if it's A, B, and C, or I could do it for A, B, C, and D really easily doing those conversions. But I do have to convert it back into polar form. So I recall, and I'll just do this over here, that for this one, we get an R value equal to the square root of 0.4684 squared plus, I have to give myself a bit more space, 8.6899 squared. And so our R value in this case is 8, should be pretty close to the second value there, but 8.7035, so that's good. And theta is equal to tan inverse of B on A, which is 8.6899 over 0.4684. Go back to the diagram if that helps. And tan inverse of that is 86.7963 degrees. So there's our R and our theta. And we can do the same thing here to give us our R value of 21.9544 and a theta value that's equal to 75.3055. And so of course we need to write our answer down as A plus B is equal to R comma theta, which is 8.7035 comma 86.7963, and the same here. Now I wouldn't mind just finishing this part off by considering this diagram as a whole, because of course the A plus B, and I'll probably only worry about the A plus B, that's A plus A, in full, but we'll do a rough drawing of 2A plus 4B. But the A plus B starts down here, moves up 7 in that direction, and then moves along 3 in that direction. And so we've got 3 and 7. My scale is obviously pretty bad, but you can see the result here is our angle 86.79 degrees or 86.8 degrees, and our length 8.7035. So there's you can see the A plus B and how that's come about. Of course, the 2A plus 4B is going to look more like this. 2A is in this direction, 4B is in this direction, but a bit longer than the original. This is now 14 because it was 7. This is now 12 because it was 3. And so the resultant vector, and I should denote a direction here because it is a vector. The resultant vector here is in that direction, and you can see why probably this angle has shrunk a little bit, but not too much, and why the length has increased 21.9544. And that's our 2A plus 4B. Okay, so let's have a look at the cosine rule. Basically, for the cosine rule, I'm going to bring this diagram down. And it's an important diagram, but I'm going to jazz it up a little bit. So we're going to start with our rough length of 7, and then our length of 3. 7 and 3. And of course, the thing about the 7, this is our resultant, by the way, here, is that is 105, which means that this is 75. And if I draw a nice little flat line here, it means that this is 75. So there, of course, if I draw that, they are either alternate angles with the 75s or co-interior angles where I connect the 75 and the 105 to form a supplementary pair. Now on the top bit here I've got 40, and that means that I can draw this new diagram, which is in fact the same as the old diagram. So let's just take a copy of it. Control copy, but with a couple of things rubbed out and some new elements. So 40 and 75 make this 115, and I don't need this information on this diagram. So it's always nice to start with your diagram that's got all the information, make sure that you get things right, and then remove that diagram or replace that diagram with a simpler version, because now we can apply the cosine rule. So remember, we're looking to find this angle and we're looking to find this length, which I'll call x. Now the cosine rule says that x squared is equal to 3 squared plus 7 squared minus 2 times 3 times 7 times cos 115. And technically you'll learn this in Math Methods Year 12, Unit 4, but of course you've seen it in Year 10, so hopefully you recall the cosine rule. It's on your formula sheet, and if I do that calculation, I get 75.74997, which is unreasonable. It's much bigger than a 3 and a 7. We need to make sure that we remember to take the square root. That comes out as 8.7034 I've received, and that is really close to our 8.7035, which has got a slight rounding out. So we're happy with that, and now we just need to find this angle here. This angle will represent the angle of the addition, and to find that angle, what I'm going to do is I'm going to find this angle, which I'm going to call alpha, and then I'm going to subtract that from 105, because the total angle there is 105. So I'm going to say something along the lines of sine of alpha over 3 is equal to sine of 115 over x, which is 8.7034. So therefore sine of alpha equals 3 sine 115 over 8.7034, and that's equal to 0.3124. So that's sine of alpha, and alpha is therefore equal to sine inverse of that. Probably overworking this a little bit now. I've kept my value in my calculator, and I've now got 18.2037 as my value for alpha. Now I remove that, subtract that 18.2037 from 105, so therefore theta is equal to 105 minus alpha, and 105 minus alpha is 86.7963, and that is this value here. So I'm happy with that, and I've got it in polar form already, so I can write down A plus B is equal to 18, no that's wrong, is equal to 8.7034, 86.7963. That's degrees. So there we have two methods for finding the resultant of adding two vectors, or scalar multiplication and addition. Now the 2a and 4b just creates this triangle, but we do the same calculations within that triangle. But I will make the note here that the only downside really to cosine rule, I think it tends to be quicker and probably easier to maintain accuracy in, but the only downside is if you have a plus b plus c, for example, it just becomes not a triangle anymore, and then you're doing the cosine rule and angles on two different triangles, and it does become a bit trickier. So I would suggest that you definitely know this component form. The tough ones are going to be done in component form. If you've got a simple addition of 2, well, then you've got a choice. All the best.